My name is Tish Shute, and 6 years ago, Ori and I met at ISMAR, and that was the beginning of all of this. And Ori, who does all the heavy lifting, is really the person to thank for this amazing event this year. Could I switch to the screen for the slides? Yes, where do I change the views?
Okay, all the fun of the fair.
Yeah.
There we go.
Oh, awesome. So basically, if you were all over at the press conference, you know that our theme is superpowers to the people, and of course that begs the question, what are you going to do with these superpowers? And that has been a question for the last 6 years. And I think, we've had very high expectations for AR and VR, and I've been very busy this year because I actually launched with Will Wright and team an app called Thread. And these images were made in Thread, and one of the early conceptions we had in Thread were these smart avatars that would actually respond to your contextual environment and your emotions. Actually, currently in the first generation of the app that we've released, they're really just stickers. But I went to the Hardware Startup Conference and tried out the Oculus Rift and Leap, the new integration, and actually was very impressed. But all around me in that conference, there were these conversations of, oh wow, what's AR going to do? What's VR going to do? We're going to change the world. And so I made this little cartoon in the app Thread, which you can, of course, download in the App Store. And I played the same game. This is my friend Sam Cuttress playing the Leap Oculus Rift game. And fundamentally, this is where we're at with what we're doing with AR and VR. So we're not saving the world yet, but there's hope. When I met Ori, we met at the ISMAR conference, and if you've ever been to ISMAR, it's the academic conference that's run for many years, and the central problem that's been addressed there for decades, actually, is the problem of presence, and you'll see many panels here. This is, a central problem: the tracking, the latency, the persistence, resolution, and optics. So, we've come a long way with this. We're not there yet, but in the meantime, the world of computing has changed. Did I slip? Yes, the world of computing has changed, and it's not now just about presence. When we're going to make AR and VR change the world, we're also dealing with this connected world, and the place of AR and VR in this connected world is crucial, and we're still figuring that out. This is just, on the horizon. This is something not yet realized, but these wireless body area networks, where you can imagine people cooperating through body sensors. And this is just. Now it's not just about presence, it's what is the place of AR and VR in this connected world. And if you'll notice our event over the years has actually evolved, and now that, we basically include VR, the Internet of Things, wearables, because computers are no longer just objects that that humans manipulate, they're part of us. And, this is some of the, the smart contact lenses, these, tattoos that can actually read your biometrics. This is all here and now, and some of this you can see in the expo. So we now have to think about, what is not just augmented reality in the terms of a visual experience, but what is it in terms of augmented intelligence? Because we're blurring the line between biological and augmented intelligence. And this is, you probably know the MOMOs. These are these little smart baby suits that let you know how your baby's feeling. And, that's a very sort of obvious progression from visual baby monitors to this, what is your baby feeling? And you're all aware that, big data has been on tip of people's tongues for the last few years. And, we just have a massive amount of data right now. It's absurd, the amount of data that we have about our world, about ourselves. But what we haven't really understood yet is how to really maximize the usefulness of these signals, and how that we can, bring them into the human world and your attention in a way that isn't intrusive, in a way that you can relate to this data. This is in fact, I think a lot of people's here view, the situation that we're in with AR and VR, is that this is what we can bring to the table right now with these technologies, is that the language of data can be transformed back into human language. This slide, I'll just explain it. It's, again, another slide I made. These are panels from the mobile app Thread that I've been developing with Will Wright and team. And, one of the things that in these images, these are emotional heat maps of, when you're sad, when you're angry. This is actually how your body can be recorded. And the little avatars at the bottom, if any of you have ever watched with your kids, My Little Pony, this show is famous for helping people understand their emotions, for putting emotions into human language. So, again, in my app, I can use little stickers and make this connection. But really, what will how will AR and VR be able to allow us to interact and understand with our emotions in as simple ways as My Little Pony did for millions of people on the internet? It's very well loved by adults and kids for this, because it helps you understand your emotions. So I think that's really why I find this panel so exciting, because everyone you see here is really working on the future of these narratives of self. How can you use these new forms of interaction with data that is a very human, tactile, visual, physical interaction? And that's what we are. We're humans with bodies, and that's what AR and VR can give us. So this whole panel is actually a kind of, I think, an exploration of that. And I'm going to introduce Andrew, who's going to come up and introduce the panel. Andrew began as a classical musician, and then he mutated into a rock and roll musician. Since then, he led the EMI New Media department. He was also involved in the founding team of Magic Leap, responsible for bringing Graham Devine to the team and for driving much of the early strategy. And he is going to bring now together the team he worked with Bjork, to authoring a view of our augmented future for her retrospective at MOMA, and for this film that you will learn about the making of from all our panel members now. So. Okay.
I wonder if this microphone's on. Yes. Good morning, everyone. Good afternoon, maybe for me. I'm a bit jet lagged, so if I start speaking in tongues, you'll know why. So thanks very much for the intro, Tish. I've met Tish a while back. We were talking originally about Will Wright and looking for applications to develop for Magic Leap, and conversations sort of evolved. And very graciously, her and Ori have invited me over to come and discuss the opportunity we had to work with Bjork, the artist Bjork, to enhance her new album Vulnicura, and also to produce the MOMA show that is just closed actually in New York. So I have a company called Third Space Agency. I developed the idea of a third space agency after having worked with, I first started off with David Bowie. I played the Worlds application he had on his website back in the 90s, which then kind of morphed into Second Life. I became very aware of the fact there was this extant next dimensional shift going on with the way, in some ways, we'd made a simulacre of the world and put it into games, and those games were kind of coming back into the world, very Tron-like. But the third space premise, it's actually a sociological theory expunged by a number of Russian academics and things originally in the turn of last century. But the idea there's a hybrid space, we're starting to populate that space. We've done a good job of it already backlogging a lot of that space with some of the efforts of things like Second Life, etc. One of the things I want to do with the Third Space Agency is basically be a connector. So the idea is to educate and inform artists and creatives to the possibilities and the opportunities afforded by working in immersive reality, using things like reality capture and motion graphics and post-production, and the kind of things that were originally, the kind of ridiculous excesses of budgets for Avatar-style films are now obviously becoming democratized, which is obviously creating a massive buzz and pushing us to the adjacent possible that's being afforded by retinal displays and those kind of things. So really, I'm really all about trying to build teams of people to come up, multidisciplinary teams to come up and work together and create a network that can deliver a creator's or an artist's vision and bring it into this next realm, this third space, if you like. So with Bjork, I worked obviously at EMI Records for a while, and I was involved with the new media elements of that. One of the things that interested Magic Leap was getting me on board to try and bring in some musical talent to start a pipeline and to almost be a kind of warm-up producer for some of the possibilities there. So we discussed with Bjork the opportunities around her MOMA exhibition and her now released album, Vulnicura. Bjork had in mind a piece called Black Lake with which to have a commission film for MOMA. So MOMA commissioned her to make a brand new piece of work. That was Black Lake. The team that are going to be demonstrating some of the things that went into the making of that film, but also some of the other elements, such as Stonemilker, which is another track off the album, were brought together basically over the period of about 6 to 18 months to try and really elucidate how we could bring Bjork's vision for what she wanted to do with Black Lake into a physical environment. So we worked with Autodesk and a number of partners, including the BBC, Bowers & Wilkins, people like Barco, a whole host of partner companies to basically create what was quite a complex project, but delivered a really stunning sort of aesthetic vision. I don't know how many people managed to get to New York to see it, but I think today we're going to talk about specifically Black Lake and Stonemilker, but we also did an augmented audio tour, which we call Songlines. We had rotational HRTF function, headphones with spatialized audio and a procedurally generated soundtrack that we work with iBeacons, which is maybe a story for another occasion. But I think basically, just to give you some insight, for instance, 3 days ago we launched Stonemilker as a VR experience on YouTube, and we've already had over 1 million plays of that video on YouTube's new VR 360 platform. This is some idea of the kind of people we were involved in this complex project. You've got a whole host of different collaborative partnerships there. The Third Space Agency pretty much brought all these together under the auspices of One Little Indian, which is Bjork's record label. And I'm really just trying to show you guys the way we try and manifest some of these ideas into this next extant realm of being able to capture things for augmented reality. Maybe the journey to augmented reality is virtual reality. Is fairly complicated, but it's a lot of stakeholder management and provokes lots of opportunity. Anyway, without further ado, because I'm fed of my own voice already, I'm going to invite Brian Pene along. Brian works in the office of the CTO for Autodesk. He's a director of emerging technology. He was actually completely paramount in being able to deliver the creative aesthetic vision for Bjork, and also to help us technologically deliver the visual impacts and do all the sort of relationship management and reality capture and things. So if you'd like to come on up, Brian. There you go, sir. Pleasure.
So, so I'm going to talk to you guys a little bit about how we made this film, give you a little bit of a peer into what we did with Black Lake. Black Lake was not a VR experience. It was heavily immersive in a physical environment. I work for Autodesk in the CTO office, and basically the last 8 to 10 years of my life I've spent really helping to build real-time, what I call real-time interactive 3D experiences, really using real-time game engines, using CAD data, using reality capture data, mashing that all up with the whole point of telling stories and engaging people. So when this project came about, it was really exciting because this was a whole new way of telling stories and really Bjork's vision. How we met, just to give you a little context on Autodesk, for those of you who don't know, Andrew and Jill Orr, who's an ex-Autodesk fellow, or actually introduced me to Bjork, and I don't think she was sure about what Autodesk did. So we invited her to come to Pier 9, which is one of our new advanced fabrication facilities that we have on the bay here in San Francisco. For those of you that aren't familiar, definitely check it out. But really, Pier 9, the whole point of it was we do software, but it's also about making things, and it's also about artists making things, and artists making their visions come true. And so it's really exists to connect hardware and software together, really high-end fabrication machinery, 3D printing, CNCs, all of this. And it's not really normal that you have this high-end production equipment in a non-production environment, but that's something that we really believe fosters innovation. So we have a whole artist in residence program there, and it's really about bringing artists in to push on our tools in new ways to make amazing things. So this is something that we showed Bjork on her way, and without a little bit more talking, I'd like to just show a quick video on what Pier 9's all about so you guys can kind of get an idea and how it kind of brings artists and machine and CAD together.
Our goal is to create the space and environment where artists are encouraged to challenge themselves to create work that the world has never seen.
You have a different way of exploring the tools and the software here at Pier 9. Those artists go out there and ask the tools and the people to do things that are just crazy, because they're right at the edge. They're like, why can't I do this?
Então, o programa aqui é muito livre, assim, né? A gente tem uma liberdade muito grande, não só conceitual, do tipo de projeto que a gente vai fazer, e a gente tem muita liberdade para aprender, para errar, para experimentar.
I've had several instances where I can just design a part in the morning and then hold that very part in my hand later that afternoon.
What makes this Artist in Residence program unique is not just the workshop that we have available to each artist, it's the supportive community that we've developed, not just within the Artist in Residence program, but beyond that with Instructables and Autodesk. By being able to be hands-on on all the equipment, they really get to understand what the tools can do and create really amazing things.
In the past, I've mostly created things with my hands. I have a fashion background. And the main new thing I ended up exploring here at Pier 9 was 3D modeling, which was not something I'd used extensively. And through this one project, I ended up learning a lot about 3D modeling and getting to explore this really interesting form. And through that, starting to see how all this new technology could have applications to my own creative process.
You might come into the program with some specific ideas, but chances are through the collaborations with other artists here, your ideas will change in unexpected ways, and you have the freedom to morph your projects into anything.
I think the point for me and the other artists here is to make things that we're obsessed about.
Failure is really how we move forward. And by failing at something, you'll find a new and unique way to do it maybe the next time around. You can really push the boundaries of what you're comfortable doing, and the creativity and the wealth of knowledge here does really enable you to make anything you can dream of.
So anyway, that's just a quick look at sort of some of the new things that we're doing at Pier 9 with fabrication. This is something that we took Bjork through and really told a story about. There we go. So after they came and visited, Andrew Thomas Wang, who was the director for Black Lake, which was commissioned through MOMA, this was really a piece that was to be the centerpiece of MOMA's exhibition. He sent me basically these storyboards of what their vision was, and the song itself is this really kind of epic operatic song. At a really emotional time in Bjork's life. And it was one of her most personal songs, I think, in work in over a decade. And it's an extremely emotional piece, but it's also a music video, and it's an installation that's really to be this experience at MOMA. Andrew basically mentioned that he wanted to create this poetic, epic narrative with the film. It's a 10-minute track on her album Volnacura, and it's this extremely live-action, heavy performance-driven piece with CG and VFX that's peppered throughout. So that was really the intent of this, and they wanted to create a space that could really immerse people within that video. It also has a sort of parallel dream world that runs alongside, and we kind of dive in and out of this, especially considering the way the song is structured. And the song has these verses and freezes throughout the video. These are, again, all the storyboards initially. And it kind of suspends with these beautiful orchestral strings, and then it resumes again with another verse, and the scrolling pattern kind of goes on and on, almost like an ongoing poem. So Bjork and Andrew mentioned that they wanted to shoot a film that could really alternate with the song structure, and to really create an exhibition for Black Lake that was a centerpiece of her MOMA retrospective. So that was sort of what it was all about initially. I saw this knowing Autodesk has so many tools for computer graphics, for media and entertainment, for CG effects. We have amazing customers like xRez, like some of the other folks that got involved. And in fact, these are some of the teams that we initially involved for this. So Wolf and Crow was brought in to do a lot of the post-production and CG effects. And xRez was brought in, who I have Eric here, who's going to talk in a minute a little bit about what they did with capturing reality. And I really believe capturing reality is an amazing, we're just at this forefront of being able to capture all sorts of data from reality, topologies, geometry, sound, and really bring that in and narrate it as a story. And I think that was a real powerful thing that was utilized in this whole piece. One of the main challenges of this whole piece here was basically that the timeline was extremely short. Everything was constrained. Everything from shooting to post-production to CG effects all started in June and July and had to be done the following year in March of 2015. So one of the first pieces that was done was the Black Lake trailer. This was produced and released to basically launch MOMA. To show you a couple of slides of basically the initial storyboard and then the final production piece, it starts out where they have her in this wound, and then she's basically, as we dive into the wound, we enter this beautiful ravine, which is kind of like the ravine where she did the song in. All of that ravine that you see there, and Eric's going to come up and talk about this, that's all reality capture data. That's not a film, so that you have this ability to have a completely unconstrained camera through that world. Here's a shot from the studio where Bjork was lying in the wound. Another real challenge of this piece was these extremely long shots that they did with these cranes and the cameras. What made that a challenge is that they had to do two separate pieces and then composite that together for the sim to really make this happen. So they used a lot of Autodesk Flame premium platform to do this work in the film, which was used for tracking, for stabilizations and all of that. So it took Wolf and Crow, I think this is a shot of the compositing inside of Flame that was done for stabilizations. Just to give you an idea, one of the challenges is it took Wolf and Crow's lead Flame artist days doing this on the desktop to basically stabilize all the shots for this. In Flame, it took about 20 minutes. So the whole point of what we're doing, again, is to really ease the friction of creating content and to really give artists the ability to tell these stories as opposed to work with, massaging the data a lot. There's still a lot of work to be done. There's amazing people doing this. xRez is another group who's really doing amazing work with the data, but eventually as that gets better, people can tell stories. Here's another shot from one of the storyboards in final production. Despite this, there was a huge amount of data. There was reality capture data, there was CG, there was 4K and 5K filming shots that were done, really challenging things. These are some of the props that we designed at Pier 9, actually. We 3D printed the prop that was on her, the wound prop that was on her chest in the film, and we used some of Autodesk's new CAD software called Fusion 360 to do this. This is a shot. What this allows us to do is not just design something, but simulate it actually as if it's built and operating, look at different aspects of it, understand things of how the object would actually be in the world before it's fabricated, as if it's fabricated. So I'm going to show you now the final piece for Black Lake trailer so you can get an idea of how everything kind of came together. So that was the trailer. Then the next piece that we basically had to do was during the filming in Iceland. The full-length film was basically shot in Iceland over 3 days back in July of last year. It took Bjork from inside lava tubes and caves like this into the rugged heart of the country's beauty. Iceland's been filmed a lot in different movies, so they also wanted to create really unique locations that you hadn't seen before in the film. The film was shot with in 4K with this red cam dragon, and it was mostly handheld, which was really challenging because there's a lot of stabilizations that needed to happen. You can see here the terrain was really bumpy, really rocky terrain. So we used Flame, we used a lot of the planar tracking capabilities in Flame to stabilize those shots later on to really help tell the story and make it less shaky. Another challenge was the environments where it was really cold, it was wet. This was inside of one of the lava tubes. It was dripping wet, cold, it was crowded. And what amazed me was Bjork was barefoot and lightly dressed pretty much throughout the entire filming of this. And despite this, she was amazingly calm. She endured cold as she sang. She actually sang the song literally as opposed to lip syncing. I think that was something that Andrew Wang wanted to really show an authenticity of the shots that they did. So this is the ravine, one of the other locations that were there. There was like 20 hours of daylight during this time, so that was also nice because we had a lot of time to shoot. Shots started at like 5 p.m. and went till like 7 a.m. in the morning. xRez captured all of the landscapes, the lighting, and all the other assets for this, and they did an amazing job. Here's a lot of these were used to basically create this whole environment for this lava that was blue lava that seeped through in the full film. The full film you'll have to see at MOMA. We may have some clips here to show you, but there was a lot of CG that went into this, or some of the CG, and so that's where the reality capture was used. But I also wanted to have Eric now from xRez come up and talk a little bit more about what they did to capture the reality, to capture these really amazing photorealistic scenes. So please welcome Eric Hanson from xRez, and he's going to talk a little bit about their process, and we'll hand it back.
Great. Thank you, Brian. Thank you, Andrew. One thing I have to correct, by the way, I noticed that we're listed as being from the United Kingdom on the speaker list. We're actually from Santa Monica, but as I say, I have a fond appreciation of British humor. So, but anyway, yeah, we were really pleased to be part of this project, you know. And the funny thing about this, our entry point for this, actually came out of my teaching. I teach at the USC Film School in animation, digital arts, as well as the work I do. And this is actually a student of mine who was the director, Andy Wang, and he was just one of the most remarkable students to go through our program. So he called me up one day and said, you know, we were doing this immersive work that involves a lot of digital terrain, and this is a lot of core work that we do at xRez. Would you be interested? Well, of course, the answer is yes. So, you know, that's and great things followed. So, again, one of the interesting things I find about teaching is the unexpected outcomes that you can get from that. But in any case, what I want to show you here is just two short videos. One, a very early test that we did for the project. And let's see, I guess I can play that now. Now, we're big proponents of reality capture. We've loved working with Autodesk over the years in this. And we think it also has large connotations for anyone involved in AR. We're doing a lot of VR dissemination of the work right now, of digital terrain and capture. But I was just talking with Brian before the session about the great opportunities that exist in AR by capturing the real world and bringing that in, as opposed to doing, you know, simplistic fabrications. So a lot of great things, I think, ahead with this tech. But I'll show you now this this very early test. And at this point, the theater was initially conceptualized as a full dome. Do I have to hit one more time to play? Just wait. There we go. Okay, so this is a really interesting formation outside of Los Angeles called Red Rock Canyon. And this was a production test we did early last year to see what we could offer the project. So this is a reality capture session done with pole photography, still witness photography, some raw video capture of a Bjork-sized friend of Andy's, just as a person to walk across a landscape. And then the trick was to integrate this into a immersive dome projection. So here the camera was tracked from that live footage, and we have the 3D model, and now it's rendered as a fisheye output for full dome. And then I think the next one you'll see here is actually represented in full dome, so you could get an understanding of the immersive nature of that. And the beauty of this is that we get handheld kind of artifacts placed into an immersive delivery, which I think is unique for full dome. Okay, so that's the early test that we did. Now, in fact, the theater became a different form by the end, but again, that kind of gave us a lot of baseline as to how we would do future work on the project. So this next video is the final capture, photogrammetric capture. We do a lot of photogrammetry, of course, reality capture with this. So this will show you the capture of the ravine, and maybe I have to hit spacebar once again. What you saw there was the use of a UAV to do aerial capture for the witness photography, but what you didn't see is a lot of pole photography done also. So we use large carbon fiber poles to create the witness photography. So I'm not sure what the core amount of images, where Greg is, but probably what, 3,000 images maybe to have created that model. So, but that's, and there's laser scanning opportunities too. So we did that as well using a Faro scanner. So we love embracing all the techniques and technology that's available to capture the real world. And the beauty of this, of course, is the flexibility that you get. You can amortize the nature of the data in so many different ways. And that's what it allowed this production to do, was to create parts of the work, to integrate the lava, to do a number of different production issues along the way. And of course, now this is being taken into VR with some of the multiple VR works that Bjork is currently producing. So anyway, this is a great project. We loved working with you, Brian. Thank you.
Thanks, Eric. So I'm just gonna, I know we're getting close on time, so I'm gonna kind of cut through some of these pieces. Some of the other stuff we did was obviously a lot of compositing with Bjork. This is a scene where she's ascending through. This is a dress that was designed by Iris Van Hepburn. We used Maya basically to composite all of that, simulate all of the dress as it was ripping off as she was kind of ascending through the scene. So that was all simulated with hair and hair simulation and particle effects and whatnot. Some of the other things that we had in this were was designing this cinema room. So Bjork really wanted to immerse people in the song, not just have them watch a film, but basically have them immerse in that. She was very, and also Andrew Wong, were really keen to have organic materials, to have a lot of elements that were highly acoustical properties, obviously, cared a lot about sound. So this was a huge challenge because we didn't just have to worry about something aesthetically, we had to worry about something acoustically sound, we had to worry about something that was organically built materials and fabricated that could be put up quickly. So basically brought in David Benjamin, who is one of Autodesk's principals in Autodesk, the Living Studio, which is based out of Brooklyn. He's an amazing architect. He uses a lot of organic materials. He had a previous exhibition at PS1 that used basically mycelium mushroom and corn to build these massive structures that are completely biodegradable. So he, working with Andy and Bjork, created this amazing sound sculpted room. So they basically brought Bjork's song into Pro Tools, did a spectral analysis of the entire song, and that actually informed the entire shape of the room, gave them a volume of the room that was sculpted minute by minute or second by second of her sound. And then he basically had to fabricate these flat panels of felt into these conical shapes that you see here in 3 dimensions that were also sculpted and informed by the sound, that also had acoustic properties involved. So here's a little clip on how he did that, and it was really an amazing piece at the end.
Data from the sound file and using that to help generate the design. The design should come from the inside out and really from the music out to the rest of the experience. It has over 7,000 unique felt cones. I mean, that's actually a really interesting and unique position to be in, like design.
So basically that was 7,000 cones that were all fabricated, individually put together from flat felt and then brought into this massive cinema room that had amazing acoustics at the end. The other thing is that they brought the speaking, because there's basically 2 projections on either side. So as you watch this at MoMA, the sound moved from one screen to the next to really inform people to basically look from one screen to the other. Even though they were basically the same film, they were like 2 different pieces. So there was a lot of 3D sound that brought people from one part of the room to the other. Real big challenge in doing that. Again, it was done and fabricated and designed all in a very short amount of time. This is a, backwards. That's a prototype of how the fabrication pieces went through. So sort of in summary to the whole Black Lake piece, you know, the beauty of this project is that it had a lot of different narratives. Normally things are done in kind of linear pipelines, and the creative teams were discovering and creating new paths the entire time along the way. So it was an iterative process in storytelling, in really making something happen and executing it. And you know, they were utilizing Autodesk tools, but it wasn't just about Autodesk tools. It was really about the amazing people and the team that was involved that were pushing on our tools as this process went. And you know, at Autodesk, we really believe in the future of making things, whether that's a virtual reality piece, an augmented reality piece. It's really about merging tools and people and new types of processes and innovation together to create something that you didn't think was possible. I'm going to skip through this last piece. This is a VFX breakdown that was actually her moving album cover. A lot of the reality capture data that was captured at Black Lake was actually incorporated into this piece as well. They used a lot of Maya hair simulation effects. We captured Bjork in 3D. Andy did on a ball bending backwards. This is for her piece called Family. It's her moving album cover piece. I'm not going to play the whole piece for the sake of time, but this is the making of it. You can go watch that on YouTube if you'd like. They used a lot of different fluid effects incorporated into the reality capture data. Also incorporated Maya's, Autodesk Maya is basically their thread or their hair simulation. This is all animated, not keyframed. This is actually animated in real time. The artist can grab it and move it through the scene and record that. So again, this is about not a static process, but an iterative dynamic process for recording animations and then making all of that come to life into this really beautiful piece that was for her piece called Family, which was her moving album cover music video. I'm going to go ahead and cycle through because we're running out of time. I just wanted to talk to you guys about one other thing because it's really important to me. It's not just about making amazing pieces like this, but it's like, how can you do this with some of the data that you capture and the other things that you create? So one of the things I just wanted to show you is some of the tools that we have now that are new from Autodesk that are allowing people to really prepare data. Data preparation is one of the bigger kind of pains of this whole process. You know, people spend tons of time UV mapping something, creating something for the web, and now as we're moving with augmented and virtual reality to mobile, and we need to have really high frame rates, and if we want to do that in real time with full parallax, we really care about how do you prepare the data and make it look good. So the whole point about this is we have a product called Memento, Autodesk Memento, which is basically a tool that allows you to capture photogrammetry and create really massive data like you saw that Eric just presented. The other thing that it allows you to do is prepare that data and decimate it down so that you could put it on the web or on a mobile tablet. You know, as 3D web and mobile data is becoming pervasive, we care about having a really easy way to get really massive amounts of data into web devices, into mobile devices, to use them for augmented reality or mixed reality or virtual reality. So that's the whole point of this. I'm going to show a quick slide on video of what Memento does. I'm going to cut it out just for time's sakes, but the point about this is taking really high-end rich reality data and crunching it in different ways, whether you're doing this for 3D printing, for fabrication, for web, for mobile, for whatever. So you can check this out online today. You can get this and download it and use it for free. It's in beta currently. So that's a tool that you can use today. As a final example, I want to show you the massive photogrammetry model that they just showed in the ravine. That contained over 16 million polygons. It was over a gigabyte of data. We basically took that through Memento and crunched it to basically put it on the web in Pier WebGL. We took this model from a gigabyte down to about 9 megabytes of data, and now you can basically view this through just a simple URL and walk through this completely freely as if you're there, photorealistically, right? Because it's reality captured data, and it's done in real time. You need really high-end frame rates for this, for VR, for AR, for whatever. So that's one example of the data that we did. Here's a final example, which is basically done in Pure VR for a Google Cardboard device. And you click a link, and you get a VR experience. So I think in summary, we're just seeing this new wave of media, this reemergence of virtual and augmented and mixed reality with transmedia storytelling going way beyond what we were able to do with storytelling before. I think there's really huge potential to utilize this for engaging audiences in entirely new ways and of really authoring reality and also of interactive storytelling. So I'm going to hand it back now to Andrew, so thank you, and please check out some of the tools that we have for this.
Thanks very much, Brian. Cheers, thanks. Thanks very much, Brian. Maybe after the presentation, you can go and see what else Brian has got in his lovely sack of tricks. I think you're understanding what we're really trying to achieve here. I mean, basically working with Bjork and a bunch of technologies that are obviously emergent with regard to authoring for potentially AR experiences. We've got a situation now where we've kind of future-proofed her data stack. So one of the things that's interesting is her as an artist in the 90s, she recorded everything with multiple microphones, far more than was needed for the actual original sessions. She thus future-proofed her content for when people started wanting 5.1 surround mixes. One of the things I'm finding, especially with broadcasters like the BBC and various other third parties with the artists and labels involved, is they're kind of trying to foolproof their content at the moment. So what's happening is when, for instance, we went and shot in Iceland, it was great to have LiDAR, and it was great to have the reality capture systems, and it was great to work in all these elements where we're able to capture performance and polygons and things, because in essence what we're doing is we're creating a bunch of data that Bjork can then revisit at a later date, and we could, in essence, remaster some of this work for an HMD or any other sort of AR opportunity. Hello. There's a gentleman striding to me with purpose. Your lab is off. Oh, my mic was off. Okay, so obviously the amazing installation piece is a huge team effort with everybody involved for Bjork at MOMA. This show in itself is going to start touring. It's just shut down in New York, and we're going to be moving around the planet, lock, stock, and barrel. One of the most interesting things from my own personal perspective, having worked in the audio side of the music industry before getting involved in visual production, is the audio component here. With Black Lake, the audio installation was an Iosono Core wavefield synthesis system. We worked with Bowers and Wilkins to run over 40 speakers into that space you saw, that space. And we had 2 parallel screens working there. And the audio system is an amazing specification. It basically allowed you to forego the sweet spot and used object-based audio to deliver a really immersive experience. Anyway, unfortunately, because of the wonders of technology, we were going to have a beam on stage, but now appearing at the back of this auditorium is Stefan Mauer from Barco. Hello, Stefan. Can you turn your volume up? Do you have any volume for us? Sound. There you go. You're going to have to speak up over the ether. Stefan's beaming in from Germany. We tried to get this working on stage, but unfortunately it's not working because of the Wi-Fi. Anyway, so this is his presentation. We're on slide 1 now, Stefan, if you want to talk people through it.
Yeah, perfect. So hi everybody, thanks for inviting me to meet in. If you could just double click to get to the next slide with the question mark. Then you see that what my big starting point is. So how to reproduce audio realistically in the context of an art installation. Is there any, and click again please to get to the next slide, is there any reality that we can reproduce in this context? Or is there any performance that we can actually capture or not? So this is the question here. Obviously there's no reality, there's no 3D arrangement of musical instruments and effects and synthesizers that we can just capture and somehow beam into the MOMA. So what we're about to do, or what we have been about to do, was to create an experience and assemble and combine the elements that are in the that are part of the artistic expression. And so for us, it was about creating a plausible and enhanced representation of art. And if you could just click one further with the light bulbs, to allow for a creative communication, a freedom of speech, so to say, for the creatives, to the recipients. And next slide, please. And to achieve that, we are treating sound as objects. So our idea is to look at sound as an entity different from standard sound systems. If you click to the next slide, please, there you'll see a cellist. This is somewhat familiar to most of you. A cellist is a musician that operates an instrument which is generating sound. And if you click to the next slide, we would represent the sound of the cello as an object. And next slide, in space. So in a 3D space, as a descriptive data of where the cello is, like the center stage. And if you click to the next slide, along with audio information. So object-based audio for us is an object which is like an entity with a set of descriptive metadata and audio content. So if you click to the next slide, the idea is to take a bunch of those elements and just create them, assemble them in a creative manner, combine them, put them into relation to each other. And next slide, please. To do that, there are a variety of options. One option is to use a tool that we call Spatial Audio Workstation, which is kind of a 3D audio, object-based audio panel, which lives in Innuendo. What has been used in the project Black Lake for MOMA. As you can see in the upper left field of the screenshot, there's a bunch of icons which represent an audio object each that can be placed and moved and animated however you want it. If you could go to the next page, please. There you see a rather abstract representation of what you have seen before in nice glossy pictures, which is the sound system that we used to put the immersive sound experience into the room that we were given at MOMA. You can see that there are different colors, different sizes of cabinets, which indicate different kinds of speakers that have been chosen for a specific purpose, to solve a specific problem, like penetrating a screen, being compact, having a specific dispersion, and that have been arranged in a manner to represent what's happening in the somehow upper hemisphere of all listeners in this space. And this arrangement has been specifically designed for this purpose, for the level that we were expecting, for the giving the transparency of object placement, of object movement, giving the possibilities for the low frequency punch. As you can see in the purple cabinets, those are all subwoofers.
So this one, 7.
Yeah. For the music that we were expecting to put on there. And if you go to the next slide, which you already did, there you see some speakers in a closer fashion, and you see the environment of the speaker system, which was the room with its acoustic properties, which was equipped with fabric, rather thick, rather organic fabric, which helped with the room acoustics a lot, because it's not only about the system, it's about the room itself. And if you could go one slide further, please. Now you might ask how to control this around 50 speakers that we put into this room. And our answer to this question is the Iosono Core, which was addressing all those speaker channels individually, which was reading the object-based audio mix in real time and rendering, it's a kind of mapping the information that is stored in the mix to the speaker system that is present at MOMA. And so it was different kind of speakers. There we had different tonalities, so we had to come up with a solution for matching them in timbre, in level, in just the acoustic properties, which we did with applying our calibration process and having this processor act as a speaker controller as well to create a uniform sonic response, so you could place a sound literally anywhere and get the same level, same timbre, same tonality. And one important aspect, since this is not a sound-only installation, is media control interfaces. How to interface with video, how to interface with light and the show control in general. And this is all processed, and just the interfaces are provided by this machine as well. Okay, next slide. So the workflow, and if you could just follow me with stepping through, is the audio work has been done conventionally. So there was a Pro Tools session, microphone recording, synthesizer playouts, effects have been used, and then the bunch of monophonic signals or 5.1 or stereo signals that we had were handled as objects were connected with our spatial audio workstation and were arranged in a fashion how it fitted the creative intent, and thus a spatial soundscape was created. The pre-production happened in 5.1 and in a speaker system that was completely different from what we found at the MOMA. So it's completely agnostic of the speaker setup, where you can just start your work in an easy environment. And the content was finalized at MOMA directly in the scenario that was supposed to be used for the show as well. And so finally we had the audio playout at the show, which brings me to the outcome on the next slide. We had a tool set given that was proven quite successful and reasonable. The audio work could happen as it would have happened in a stereo or 5.1 environment with conventional gear and the workflows that were already standard for the sound professionals involved in the project, but giving a possibility of 3D sound design aspects that is unparalleled with other systems and standard playback systems, and the flexibility in shaping the reproduction setup, which overall, which is my last slide, brings us to an outstanding audiovisual piece of art, pushing the envelope a bit further, I would say. And so I would like to thank you all with my last slide for being here and for being part of this exciting Black Lake project.
It's a bit random, but we tried to make the technology work. We've now got beam number 2 working as well. So audio is a particularly interesting preoccupation because I think the ears need to support what the eyes are seeing. And so we've developed some workflow tools with both Barco and also now with the BBC and a company called Two Big Ears. Beyond Black Lake, which was obviously an installation piece with speakers to reproduce the audio to accompany the video pieces, we also ran with a VR 360 piece which has just been released on YouTube 360. It originally ran in MOMA PS1. We developed our own HMD using iPhone 6 Plus and a third-party viewer called FreeFly. Basically, the gentlemen who are about to talk to you now, Varun, Nair, and Chris Pike, developed a really interesting real-time binaural rendered audio mix for Stonemilker. Unfortunately, that's not appearing on the YouTube 360 output because the language to be able to stream object-based audio is currently still in the standardization process. So Fraunhofer with MPEG-H and a number of other standards bodies are trying to deliver those things. But for the actual experience we put into the HMD, BBC head of audio research there, Chris Pike, and Varun Nair, who's one of the co-founders of Two Big Ears, will now discuss some of the opportunities and challenges that we had to deliver audio for the Stonemilker film. Over to you, Varun.
Thank you, Andrew. So it's as a technologist, it's quite easy to talk about technology, and it's great to have great technology. But I think as technologists, we also have we are also responsible for ensuring people have a good workflow to deliver great content, and that's what my job is about. So at Two Big Ears, we developed 3D audio, spatial audio rendering technology for headphone systems. So it's completely software-based, works over any pair of headphones, so you can hear sounds from above you, below you, or any point in space. And we also do a whole bunch of other acoustic modeling algorithms that works with game engines and mobile devices and so on. But for Stonemilker VR, it was an interesting problem to solve. There are quite a few 360 VR projects out there, which look great, but most of the sound is still stuck in 2D. It's just stuck on your headphones. It doesn't really respond to head orientation or the actual virtual environment. This can be quite easy to do, or easier to do if you're using a game engine, because game objects automatically have all that metadata about where they exist and how they're moving around in space. But if you're working with video that's pre-recorded, you don't have any of this data. So when you actually need to position sounds, you have an interesting problem. Typically, with movies, a lot of these sounds are placed manually, but with VR and HMDs, you have the additional complication of taking head orientation into account. So if Bjork is singing right in front of you, if you move your head, the sound should react that way, and should sound realistic, and should sound like it's coming from that position. So as a baseline, we already had this great technology that could work really well across devices, across platforms, but it was really important for us to ensure that Chris had a really good workflow, so he could work with Bjork and Chris Elms to deliver a great audio mix that works across devices. So we developed an end-to-end workflow solution, which is based off regular audio workstations. So any sound designer, musician, they already work with such environments and are used to working with digital audio workstations. So we developed a whole new tool set that augments a lot of the functionality within digital audio workstations, so they could still author content in a linear workflow, but also make it reactive based on head movement and head tracking data. This was really important for us because we wanted to ensure Chris and everyone else had time and the flexibility to be creative with the mix and not really bother about the technology and what happens behind the scenes. That was our job. So it was important for us to have a system in place that could give them feedback so they could work on the mix, but also preview the mix at the same time directly on a virtual reality headset, so that they could understand what the end user is going to listen to directly while they're working on it. And this also created lots of room for iteration, because that's really what a lot of the creative process is about. It's about iterating through ideas and finding that sweet spot. And we really wanted to enable that. So the whole setup works with an audio workstation where primarily as a creative person, you just work with tools you're familiar with, and you mix with tools you're familiar with, and you can preview directly on a VR device. And then you just export it out into a format which our engine on the mobile device would then use all that metadata and information to recreate that mix in real time based on where the user is looking. And we can also deal with positional data and not just head tracking, which makes it really interesting. But then we can also augment that layer even further and bring in real-time data, whether it's data from the real world, augmented data, and it really opens up a lot of possibilities. So you can combine a linear workflow with a non-linear workflow and open up lots of room for creativity. So I'd like to hand over to Chris now to talk about the actual mix and the process behind the mix. All yours, Chris.
Great. Can you guys hear me okay?
Yes.
Wonderful. Hi, hello from the UK. So yeah, as Varun was saying, I worked on this mix for the Stonemilker VR video. It was a collaborative effort between myself and Bjork and Chris Elms, her engineer, also with a great deal of support from Varun on the workflow and the tools. And we were working across the Atlantic on this project as well, which was a very interesting experience. So yeah, my role is to kind of apply immersive audio technology to programs at the BBC, the broadcaster in the UK. And we're trying to create immersive audio experiences for the audience. So I was privileged to be invited to join this project on the Stonemilker VR video and also the MOMA audio in New York. It's a novel experience producing audio for VR if you've not done it before. As Varun said, they put some great workflow tools in place to make it easier. It really helps when doing this kind of work for a video-based VR project to be using the existing workstation tools that you used before. And so a lot of it's very familiar, except you have to keep diving into this VR headset display. So in the future, I think if you can have the pass-through options or a head-up display linked to your workstation, then that would really speed things up. But we're already making great progress on the workflow. So if you could go to the next slide, Varun, that's great. So I guess with my few slides here, I'm just going through some of the key things we were trying to achieve with the mix for this video. And obviously immersion is one of the main ones, being a VR project. The first thing I should say is that to get that sense that you were present with Bjork on the beach, then her vocal movement had to be accurate. So I worked first and foremost to get that movement, that sense of distance accurate using the panning tools that Tuba Gears had created. The other aspects for immersion were really to get that sense of being on the beach with her. So there were some wild track recordings made by another engineer after the video shoot, and so we mixed those and edited those to fit the video and supplemented them with other Atmos recordings to get the full VR impression, because I mean, you may have seen some stuff on audio recording already, but you can't just use a normal mono or stereo microphone for these things, because people need to be able to turn in the environment, and the perspective, as Varun was saying, needs to adapt. So a lot of the time, as with sound design in films, we piece together the atmosphere from multiple recordings to get that surround sense. the video starts with some atmosphere recording, but obviously it's a music video, so quickly the music begins. And there were 30 string players who performed on the album, the recording, which is what this is based on. We used the close mics, clip-on mics from the strings, so we had all of them individually recorded. And part of the sense of immersion was to surround the listener with the strings, so they were kind of in the round, and you could turn and explore the arrangements of the strings, which is something Bjork was really keen to achieve. By turning, you weren't just looking around the world, but you were exploring the music. So we had those close mics, and I used also an 8-channel surround reverb in the system to get everything to sit together, have all these individual string recordings feel like they were created in the same room. They were, but a reverb helps to kind of sweeten that process. So the next aim was intimacy. A key part of this song and the whole album of Bjork's is the closeness, so the intimacy of what she was going through, and that was a real aim of this film and experimenting with VR technology. So the 360 camera fielding really provides that sense. You're present with her, experiencing what she's experiencing, and that needed to be matched with the audio. So one of the first things we decided to do was to strip out all of the electronics from the album track. So it's just laid there, the strings, the voice, and the slight Atmos sound. So we already were able to achieve a very close feeling using these clip-on mics, which gives you a very dry, close feeling to the string sound. We also used a very dry vocal sound, reducing the reverbs that are in the album track. So that all helps to contribute to this feeling of intimacy, which is provided by the video. The final thing we really had to go for was impact. Sorry, Varun, I've been talking without skipping you on the slides, but we're on impact. So that should maybe say that this is all about music as much as all about impact, but that's the important thing to remember when trying to create this. It was a music video, not a first-person computer game experience. So the sound quality and the impact of the music is still key in the mix that we created. One thing that was a real challenge was when in the chorus in the video, Bjork multiplies. If you've seen the video, you notice that at the chorus that there appear several of her in the shot. That was a real challenge for the audio as soon as we came to look at this project. Should we try and create that sense that there are several of her around, or should we just keep it straight and have the music come to the fore? And that was the obvious choice in the end. So Bjork's vocal goes mono at that point, and it then has that sense of being inside your head. So when I say it goes mono, what I mean is that most of the sounds we were creating here were going through the two big ears binaural processing, but we also had a separate bus in the mix, which gives us direct in-the-head sensation by creating mono sound, so the same audio coming from both the headphones. This allows Bjork's voice to enter into your head whilst the world is still surrounding you. We also did this with the double bass to create that impact, the low end that you get from a nice mono sound that's not got that spatialization on it. And also I think it's quite apparent when you start mixing this stuff that bass sounds being linked to a point in the room isn't always the most sensible thing, especially when you can't see the source of the bass. Yeah, so the final thing I just wanted to say is that when doing this mono approach with the vocal.
Is he on or off? He's off. Maybe you want to wind up, Varun?
Yeah, sure.
I'm back. Oh, you're back. Currently, so not appearing in this film. Yeah.
Okay, I'm not sure where we got to, but the final thing I wanted to say was that about interactivity. So towards the end of the piece, there's multiple Bjorks in the video coming from different directions, and we went back to the binaural technique and used the audio to steer the viewer's attention. So it's like she's beckoning you at different sides with the audio, and that really encourages the listener to turn to the action. Good stuff, that gives you a little overview of the techniques we were using.
Thanks very much, Chris.
Great, thanks. Enjoy the show, guys.
How are you doing? Okay? Okay, so thanks very much, everybody. We've horrendously run over time, but just an insight into the world of the production pipeline for being able to deliver the artist Bjork's vision and also being able to future-proof content for an augmented reality layer. I really want to thank all of my contributing guests, without whom this very large, complex production for MOMA and also the album promotion for Volnicura couldn't have happened. I also want to thank Tish and Ori for helping us to come down here and show you all a bit about some of the creative work we're doing to try and push the boundaries of how we author for AR. Thanks very much.